Hi, hello everyone. Welcome back to my YouTube channel, My Intuition. I'm Dr. Prasad Puthiyillam. Continuing my class series on Chemistry for Computer Science Engineering stream, VTU Technological University, with subject code BCHES102 My video classes includes the important questions and the answers, supporting answers in a series of way. It also indicated the revised Bloom's taxonomy level question level. I am taken as 11.4 for almost all the questions, because once you are pakka with or sure about level 4 questions, then generally exam question paper you can see level 2 as well as level 3 questions. So level 4 questions, if you study, you can able to answer level 3 level 2 questions easily. So I covered almost half of the module. Now this particular class is for disposable sensors in the detection of pesticides. So some of the questions: evaluate the effectiveness of disposable sensors in detecting a variety of pesticides and compare their performance to traditional analytical techniques. Analyze the potential limitations of using disposable sensor for detecting pesticides in complex matrices such as food and soil samples. Compare and contrast different fabrication techniques of disposable sensors and evaluate their impact on sensor performances. Evaluate the importance of choice of sensing material in development of disposable sensors for pesticide detection, and discuss the advantages and disadvantages of different types of sensing materials. Analyze recent breakthroughs in the field of disposable sensors for pesticide detection, including advancements in sensitivity, specificity, and selectivity. So let us see the types of pesticides which are getting detected, or possible pesticides. They are grouped as organophosphates, consist of a carbon, hydrogen, and mainly phosphorus as the main element, called as organophosphate. They are widely used in agricultural, and they are toxic to humans and other animals. Therefore, we need to detect it at its presence. Its detection can be very important for monitoring the pesticide residues in food as well as water. Pyrethroids. Pyrethroids are pesticides used in insecticides and can also be toxic to human and other animals. Their detection can be important for monitoring their presence or residues in food as well as water. Neonicotinoids. Neonicotinoids pesticides are widely used in agriculture and can be toxic to bees and other pollinators. Their detection can be important for monitoring the pesticide exposure in the environment. Glyphosate. Glyphosate is a widely used herbicide that has been linked to the health and environmental concerns, and detection can be very important for the food as well as water. Now, choices of sensing material. Which are the choices we have to sense those type of pesticides and related organic materials? Let the train to go. Chemical properties of the target pesticides. Different pesticides have different chemical properties such as molecular weight, size, polarity, and functional group. These properties influence how the pesticide interacts with the sensing material and affect the sensitivity and selectivity of the sensor. Therefore, sensing material should be chosen based on the chemical properties of the target pesticide. That means based on the target pesticide, it will be having different size, it will be having different molecular weight, or their polarity, the charge separation in the molecule, or the functional group present in that one. Based on that, we have to identify, or we have to choose the material which will sense or which will react with that one. When they react or when they combine with them, then only the possible chemical changes like a redox reaction or any other related changes in color or any other things will happen. Therefore, chemical properties is very important as one of the choices of sensing material. Then sensitivity, the sensing material should be highly sensitive to the target pesticide to enable the accurate detection at a very low concentrations. It can be improved by using materials with high affinity for the pesticides, such as the MIPs, that is molecular imprinted polymers. Selectivity, it should be highly selective to the target pesticide to minimize the interference from other compounds in the sample. Selecting means selecting only the particular pesticide that we want to detect. Our sensor should selectively detect that particular pesticide only. Therefore, it can be achieved by a material which are very specifically recognizing the target pesticide, such as antibodies or aptamers. Stability, the sensing material should be very stable under the conditions of use or during the storage also. This is very important to ensure the reproducibility and reliability of the sensor performances. Now, some of the common sensing materials which are used are like conducting polymers such as polyaniline, used in the detection of organophosphate pesticide. These polymers can be modified with the specific chemical groups which are attached on the surface of the sensing material, which can react with the pesticide, then causing a particular required changes in the electrical conductivity, which can be measured. Molecularity imprinted polymers, that is MIPs. They are the synthetic polymers which are designed to selectively bind to a target molecule. Target molecule means the pesticide that we want to detect based on its molecular shape and functional group. Antibodies, they are proteins which can specifically recognize and bind to a target molecule such as a pesticide with a highly affinity and specificity. Affinity means it will attach at greater depths and they are very specific also. Aptamers are short strands of nucleic acids which are selectively bind to a target molecule such as pesticide based on its shape and chemical properties. Carbon nanotubes, they have been recently started using to detect the pesticides such as chlorpyrifos and atrazines. These sensors are designed to detect the changes in the electrical conductivity on the nanotubes, and that is indicating the presence of the pesticide. Enzymes such as acetyl cholinesterase, which have been used in the detection of organophosphate pesticides. These enzymes react with the pesticide, causing a change in color or the fluorescence that can be measured. Then quantum dots, they are the semiconductor nanoparticles which are used, which are having used in disposable sensors, use of the fluorescence property or even the electrical conductivity to detect the pesticides. Metal organic frameworks, that is MOFs, they are the porous materials, material with pores, holes in that molecular the structure, which can be modified to selectively absorb. So wherever the holes are there these pesticides can go and pack that holes. So it can be used to absorb, just like sponge. Okay, so it can be these metal organic frameworks can be used to absorb the specific pesticides. And the sensors use MOFs. They can detect the presence of pesticide by measuring the changes in electrical conductivity or a fluorescence. Now, optimization of sensor performance. Selecting the appropriate sensing material is very important. Some of the commonly used sensing materials include the enzyme, antibodies, aptamers, molecular implement polymer, just how we discussed. Each sensing material, it has its own advantages and limitations. Therefore, choice of sensing material, should depend upon the specific pesticide which has to be detected. That means for different pesticide we should have different type of disposable sensors right now. Improving the electrode design, the size and shape of the electrode, the distance between the electrodes and the materials used to make the electrodes, all very having very importance towards the performance of the sensor. So most of the pesticides sensors, disposable sensor used for the detection of pesticide based on the electrochemical reaction. That means electrodes required, electrode to detect the material. Then we need to have a reference electrode that you already studied, the galvanic cell, then how the electrochemical cells are formed. So the same concept I used here. So the electrode, the distance, the size of the electrode, shape of the electrode, and the distance between the electrode all has to be optimized to get a better result. Optimizing these parameters can improve the sensitivity and the stability of the sensor. Enhancing the electrolyte composition. Electrolyte means the medium which we are using, that we call as electrolyte. Any medium which carries the charge, movement of ions, we call it as electrolyte. It will be having varying pH, acidity to basicity to neutrality. Any possibilities are there. It will be having varying conductivity. Conductivity means the possible movement of ions through the solution or medium. And ionic conductivity is the movement of electrons through the medium. Ionic strength of the electrolyte, it can all influence the sensor responses. Selecting the appropriate electrolyte can improve the sensitivity and selectivity of the sensor. That means we should have a chemistry idea regarding the medium that we are using there, its pH, its conductivity, as well as the number of ions possibly present in that. Number of ions we calculate by using the normality concept. We can calculate and say how much ion concentration is present, or what is the concentration present there. Controlling the operation conditions. The operation conditions of the sensor, such as the temperature, humidity, flow rate, all impact the sensor performances. So we should have a better control of the environment that in which we are using, operating conditions. We have to consider this and optimize it to get a better performance. Miniaturizing the sensor. Miniaturizing is bringing the scaling down, making it smaller and smaller. That we call as miniaturizing. A bigger, bulky one, making it to smaller one. Just like our older computers were very big. In our we have very small computers, mobile phones itself. So that is called as miniaturization. Okay, so it can be achieved by the microfabrication techniques to make the small electrodes. Microfabrication means the fabrication, we are making the electrode in the micro level. Micro, already know that our motherboard, everything it is in micro level. Okay, so microfabrication techniques are used to make very small electrodes, integrating to the microfluidic channels. Microfluidic means a very small volume of the samples or electrolytes are used, and using wireless communication system for the data transfer. That is the miniaturizing the sensor. Now, general sensing mechanism, how it is happening. Disposable sensor for the detection of pesticide typically employ a electrochemical sensing mechanism, which I already said. They use electrodes for the sensing. It involves the use of electrodes and sensing material that reacts with the target pesticide to generate the electrical signal, which is then measured and analyzed. The sensing material used in disposable sensor for pesticides detection is typically a chemical compound that can selectively interact with the target pesticide. For example, the sensing material may be designed to selectively bind to a specific pesticide or class of pesticides while ignoring the other compounds that may be present in the sample. That is, it should be very selective. You should detect only the targeted pesticide only, not the other organic material present near to that. When the sample is applied to the sensor, the target pesticide interacts with the sensing material, which causes a changing electrical property of the material, of the sensing material. This changing the electrical property of the sensing material, which will be transduced. Different materials such as platinum, gold, or carbon are used as a support to the sensing material, and further these electrical signals are generated by sensor, are amplified using the electronic circuit and the software, transduced, and analysis may involve the comparing the electrical signal generated by the sensor with a reference signal, or using a machine learning algorithm to identify patterns in the signal that corresponds to the presence of the target pesticide. Some of the fabrication technique used for this disposable electrochemical sensor for a pesticide, like screen printing. You already heard about screen printing. The same concept is used here. It involves the deposition of sensing material onto a substrate using the mesh screen stencil. The substrate may be made of different materials such as glass or plastic, and the screen printing technique is widely used for the production of disposable sensor, having very low cost and having scalability. Means we can produce a large amount at a time. Inkjet printing is a normal or printing that we use in our press or everywhere we use it our home as inkjet printing. Same, the ink is replaced with the material that we wanted. The sensing element is used as the ink, and the same inkjet printing technique is used to prepare the sensor, the sensing element. Spray deposition, even it can be sprayed, or the spraying solution of the sensing material to a substrate using a spray gun or a nebulizer, and it is very simple and scalable method for producing disposable sensors, but the results are maybe non-uniform, but still we will be able to detect the pesticide. Thin film deposition, either by evaporation, the solvent is taken in which the sensing material is there, then the sensing material is dissolved in the solvent, then it is poured to a pot, and the solvent is evaporated, so we get a deposition, and that deposition of the sensing material, that is called as solvent evaporation technique, or it can be sputtered on that. The thin film deposition technique allows the precise control of the thickness and composition of the sensing material, resulting in a very highly sensitive and selective sensors compared to the spray one. Microfabrication, micro means very small level. Using microfabrication such as photolithography or etching or patterning to a substrate. That means we are taking a substrate, to that we are creating, we are etching it, we are scratching it actually. That is known as lithography. Writing, that is the word of lithography actually. Photolithography means we are using light energy to make the drawing or the whatever needed on the sensing material. The sensing material is put on the substrate material by the method of drawing. That is called as lithography. For using photolithography or etching method, it can be used. That separately we'll see what is lithography and etching. That right now you understand that it is simply writing, a method of just like writing. Etching means scratching, lithography means writing. Okay, so microfabrication allows for the precise control of the sensor geometry and sensing material properties, resulting in highly sensitive and selective sensors. Some of the main applications or key applications in agricultural monitoring. It is used to detect the pesticide present in soil and water, so that the farmers will get the idea about the usage of the pesticide to be used or not to be used, so that it will have can control the environmental impact. The pollution can be controlled. It is used in food safety testing, where the food materials are packed or prepared. The possibility of getting these pesticides through the farm only, agricultural farm only, possibilities are there to further to check it presence of the pesticide for the food safety. It is used. Environmentally monitoring, because pesticides we use in the agricultural field, it will go to the water body, air as well as soil. That has to be detected, it has to be checked, and we need to have proper control over that pesticide pollution. Biomedical applications, it is used to monitor the pesticide in the humans or animals, to avoid the potential health risk, or the pesticide may accumulate in our body. After many years of usage, pesticide will accumulate in our body and it will cause some health issues to our body. It will dissolve in fat. Some of the pesticides will dissolve in fat and it will remain the industrial application. These sensors can be used for monitoring the concentration of pesticides during the manufacturing process. Means while we prepare the pesticide we need to kill the pest in our agricultural field. That is for our to get more yield we use it. So when we prepare the pesticide in the industry, there also we need to check how much pesticides are formed or getting formed, what is the quality of the pesticide. For that also the sensors are used. Advantages compared to the traditional method, like it is very portable, they are very small in size, and it can be taken to the field use, uh, compared to the chromatography or gas chromatography or liquid chromatography, which are bulky, and it is a laboratory equipment. But whereas our disposable sensors are very portable, very small one. Speed, the detection speed, the results are we are getting within minutes or within hours, compared to the traditional, which takes hours or days to get the results. So it's a faster decision making and response to the potential pesticide contamination. Cost effectiveness, compared to the traditional analytical method, which are costly, the equipments are very costly and the experts are required to operate that equipment, whereas the disposable sensors, it is very comparatively cheap, and even small scale of farmers and non-specialist can also operate it. User friendly, these are very friendly to handle. Minimum training required to use the disposable sensors compared to the traditional analytical technique. Reduced sample volume, we need a very small amount of the sample to detect the presence of the pesticide, compared to the large volume required for the other analytical techniques. Real-time monitoring, we can check the presence of the pesticide in the real way, not like sticking a sample, going to a lab and doing the test. There only the spot itself we can do the testing, and it can continuously monitor, not only testing one this person taken out after half an hour, another sensor is taken. So will get a continuous monitoring, hourly monitoring or everyday monitoring can be, it is possible, since it is a portable device. Okay, so the traditional method, it needs a collection of the sample, transport to the laboratory. We give the relayed or delayed response time. Limitations, it also has some limitations. Sensitivity compared to traditional technique, we may not get highly sensitive results. Accuracy issues are there. False negative or false positive results are also possible. Therefore, we have to compare with that of normal traditional techniques also. Specificity also, specified pesticide to detect in from among a group of pesticide, it may lack, it may not be giving the proper exact result compared to traditional method. It may give false positive or false negative result here also. Reliability, disposable sensors can be affected by environmental factors such as temperature and humidity, which could affect their performance. Therefore, the reliability is also not as good as that of traditional analytical technique. Sample preparation, and it may require specific sample preparation method that can be time consuming or challenging to perform, especially in the field settings. Traditional analytical technique, on the other hand, often have well established sample preparation methods. Therefore, they know everything. Once the sample reaches, automatically the people will do. So here, the sample preparation may take some little bit confusing for the person who is using it. Data analysis. Disposable sensors often provide the qualitative or semi-quantitative results, which may not be sufficient for some applications that require precise quantification of pesticide level. So data analysis are some of the issues which still has to be tackled compared to the gas chromatography or mass spectroscopy. Some of the recent breakthroughs which is happening right now, or very last year, or at present what is going on on disposable sensor for the pesticide. Nanotechnology concept is used using gold nanoparticle to detect the organophosphate, are giving better accurate results. These are the recent developments. Artificial intelligence is getting used. Artificial intelligence is combined with the disposable sensors and giving better result, which is tested on the apple sample. The presence of pesticide in the apple sample, which is giving a better result, far better result compared to traditional analytical techniques. Microfluidics research, which involves the manipulation of very small volume of fluids in microscale channels. And one of the recent research study shows that the electrochemical sensor used to detect organic phosphorus in water sample, giving a better result. Please do subscribe to my YouTube channel and subscribe myself, Dr. Prasad Puthiyillam. Thank you very much.